Hello YouTube, CJ at Georgia Astronomy, and this is a viewer requested video. This comes from Alan G over in the UK. Alan has sent over some of his data on a project he's working on, which is NGC 2359, which is Thor's helmet. And the question came across as he's working on this, he's also checking to see where he's at by running through APP. And the question he had is, why do I have this much gold, and what am I doing wrong? What am I doing right? How am I getting so much of the gold in here? How do I take it out? One of the things we need to realize when we think about when we're shooting SHO, or what we call the Hubble Palette, and the reason why it's called the Hubble Palette is when the Hubble is taking photographs in space, and it's using those three filters, which is hydrogen alpha, sulfur 2, and oxygen 3. When the information, which is basically taken in black and white and it's sent to Earth, and the NASA is putting these photos together, they're assigning their own color values to them. What is most popular is what is called SHO, and that is we're putting sulfur 2 into red, we're putting hydrogen alpha into green, and we're putting oxygen 3 into blue. When it comes out, it's more visually appeasing, I guess, pleasing. There we go. It's more visually pleasing to the eye. And so a lot of the photographs that are released of the Hubble, when we're looking at different type of nebula and stuff, NASA has coded it as SHO RGB, and it's just become synonymous as being the Hubble Palette. You can do any particular way of photographs with those three, and you can assign whatever color you want to those filters. So HOS is very popular, and I think I've heard is probably the more scientific way of looking at gas in space, because you obviously can't see gas, not as a color so much. You have to give it a color combination. So HOS, you have SHO, HOO, OHS. There's any multitude of ways that you can assign colors to gas. And basically, narrowband, you can be extremely inventive, because there is no right or wrong when it comes to narrowband imaging and assigning colors. It is whatever you want it to be. Whatever makes you happy, you can make it. However, again, Hubble, typically those are released as SHO. It's very popular, so a lot of us choose to shoot in SHO. However, when we do shoot SHO, typically the problem we have is the green, because green is assigned to hydrogen alpha in this particular case, and because there is so much hydrogen alpha gas, it tends to be the predominant color, and it's actually overpowering. Programs such as pics actually has a script to remove green, to take the green bias away, so that the entire image is not greened out. I've showed you how to do that in APP by adjusting your multipliers and also injecting the other colors into it to try to offset it, because it's so powerful. But here we're in a case where we don't have a lot of green emphasis. We got some that's in there, but we have a lot of gold emphasis. And so the question is, well, why? Why do we have that? And if we go back to our lovely RGB color wheel, which we've gone over before, basically you have the dominant colors. You have the three. You have red, green, and blue, and they all are assigned a pixel value, let's say of 255, and that's an absolute value for that pixel to be 100% red. It's 255 in order for the pixel to be 100% green, and then it's 255 for a blue pixel to be completely blue. You can never be more red than or more green than. It is set. That is the color RGB. But then to get any of the colors on the outside of it is the combination of those two pixels of intensities applied to each other is what gives you the color. So in this particular case, if you gave equal full parts of red and green, you will get yellow. So it's a full value here of red, full value here of green, gives you the color of yellow. Now, if you don't have enough of a particular color, then it will lean towards whatever the bias is. So in this particular case, where we have a very gold or red image, is because we're favoring more sulfur gas. In fact, if you put these two side by side, we have sulfur 2 over here on the left, we have hydrogen alpha here on the right. You can see that these are fairly equal in the amount of gas that's there. The exception here, and these are of equal length, both of these are like 5,180 seconds combined per per stack. So same amount of images with the same amount of time in both of these stacks. However, it appears we have just a little bit more sulfur in the side than we do of the hydrogen alpha. Now, bearing that in mind and the way we're looking at it, if you said that the sulfur, if it is indeed more so, and I would assume it is based on how we're assigning the colors to it here in APP, that would be the baseline. So that would be the absolute of 255. But in comparison, there's not as much hydrogen alpha information there. Hence, it is not going to the yellow or to the green side. It's shifting towards the red because we have the red. So we're getting this orange color. So that would explain why we're getting that. Now, when we look at other examples of people that shoot NGC 2359, let's bring this back over. It seems to be the default is a lot of people use HOO, and that's helium, oxygen, oxygen. So we're putting hydrogen alpha. We're putting hydrogen alpha into red, and then we're assigning oxygen into both the blue and the green channels. Not all of these are done exactly as HOO. Some of these have been done as OHO, OHH, and then I have seen a few that actually are done in with the sulfur channel, but it's more or less very minimalized, and it's almost like just for like a pickup color, because they may be doing 10 hours of hydrogen alpha, 10 hours of oxygen, and then they're only doing like 2 hours of sulfur. So I'm sure that that the way that they're working it into their program is they're trying to get different color variations by using the sulfur. However, most of these have been done with HOO loaded with LRGB. So they're using the LRGB more for the star color and to pick up some color of the nebula, especially the darker parts of the nebula, the dark nebula that's associated in there. But then they're using the HA and the oxygen in order to pull the gases out in order to give the color that they're trying to get. So while it's not completely unheard of doing SHO on this object, it just seems to be because that sulfur and the hydrogen are so interconnected and meshed that tightly that it's almost kind of pointless. So you might as well just do HOO instead. Or you could do SOO, I guess, if you really wanted to. It's just, again, it's whatever color you assign to it. So in this case of Alan's picture he's got here with what he has, if he wants to take the gold out of there, more of the gold, we would do the same thing we would do if we were trying to get rid of all that extra green that we have when we're on the typical way that it happens, just by either bumping up the additional colors into that same channel to kind of cancel them out or to reduce it, or to decrease or increase our multipliers here. So in this particular case, though, I'm just going to add in green and blue, and that's going to tone down that gold, and we're going to go back more towards a yellow, almost like a yellow kind of a white. So while I've got a little bit of red that's in here now, with a little bit more green that's dominant, and then more of the yellow, I can do that. At which point I can take it into HSL selective color, and I can adjust the hues and the luminance of it, and to bring it up or mute it, depending on what I'm trying to do. One of the things that you could do in this particular case, if you did want to eliminate hydrogen alpha altogether, then just remove it from the color channels. Since you've already assigned it into the sulfur 2, now we're going to come up with like a yellowy kind of look because we've removed that red aspect of it. And then, of course, I can also remove the blue completely out. And if I do that, then I'm going to get something along these lines, which is just kind of just plain white because I'm only using one channel. If I go back in and add the blue channel and the green channel of oxygen, so I'm doing basically SOO is what I'm going to be coming up with here. I'm going to get that red. And you'll see, because again, it doesn't have a lot of oxygen pulled in here. You'll see right here there's a little bit of whiteness that's kind of going on, which would probably actually be blue, and that is because there's very, very little information that's in there. This is actually turned, but there's the little bit of oxygen there. So I would suggest going and getting more oxygen data to add to it, and either running it as SOO if you have a stronger sulfur signal in there, or even then to just cancel out your sulfur altogether and then just go to HOO, which would be your red channel, and then blue-green. for your oxygen, which is pretty much going to give me the same effect, right? So it's just kind of depends on what you want to do and how you want to get there. Not everybody has to be the same. Again, one of the benefits of narrowband is it's open to interpretations. You can assign whatever colors you want to it. It does appear, though, a lot of people do try to follow the same suit on objects like that. So I'm not 100% sure why a lot of people would consider doing or eliminating the sulfur channel altogether. Again, other than the fact that it looks like they're both completely on top of each other. So you're not really making much of a difference. And I would think that hydrogen alpha is easier to extrapolate. I know in a lot of cases I get better data on hydrogen alpha than I do sulfur, but it all depends. And obviously there's a lot to play into that as far as seeing conditions when you're shooting, et cetera, et cetera. So I don't know. If you have experience on shooting Thor's helmet, I'd like to hear your side. I would like to hear, why you process the way you do. And if you have examples of it, we'd love to see that as well. So if you have more information on shooting Thor's helmet, we would love to hear from you. So please be sure you put them in the comments down below. If you have pictures to share about it or some unique way that you've also processed it, we'd love to see those as well. So feel free to reach out to the website and the email address that's here on the YouTube channel on the About. Feel free to send them in to us along with your name and your information on it, so that when we do share it on a future episode, we can give you the proper credit that you deserve for your photo.